Day 5, print queue. Satisfied with their search on Ceres, the squadron of scholars suggests subsequently scanning the stationary stacks of Sub-Basement 17. Bro, you can't throw that many S's into a sentence. I'm amazed at my ability to just read through that. Even Ceres has the S sound. Satisfied with their search on Ceres, the squadron of scholars suggests subsequently scanning the stationary stacks of Sub-Basement 17. Oh, wow, I totally lost at the end. Hold on, I can do better. Satisfied with their search on... Oh, no, maybe I can't do better. Satisfied with their search on Ceres, the squadron of scholars suggests subsequently scanning the stationary stacks of Sub-Basement 17. It's a wild sentence. I'm already loving this. The North Pole printing department is busier than ever this close to Christmas, and while the historian continues their search of this historically significant facility, an elf operating a very familiar printer beckons you over. I'm curious what this is. What is the very familiar printer? Cool, it's another reference to Advent of Code 2017. I'm going to have to go through and do all of them. It seems like there is some greater lore, and there's like an Advent of Code cinematic universe manifesting. It's awesome. The elf must recognize you because they waste no time in explaining that the new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services. Safety protocol clearly indicates that new pages for the safety manuals must be printed in a very specific order. The notation X pipe Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. Okay, cool. So we're already like creating like a dependency type of thing here. Okay, the elf has for you both the page ordering rules and the pages to produce in each update, your puzzle input, but can't figure out whether each update has the pages in the right order. Oh boy, okay. Wow, the example's already big. Okay, this is scary. Number pipe number, number pipe number, number pipe number. So this gets piped to a bigger number, this gets piped to a smaller number. I'm guessing there's no rules. It could be any size number on the left or the right hand side. What do we have down here? Is this a line? Is this a line? Are there new lines here? I can't quite tell. But it doesn't matter. The first section specifies the page ordering rules, one per line. The first rule 47 pipe 53 means that if an update includes both page number 47 and page number 53, then page number 47 must be printed at some point before page number 53. 47 doesn't necessarily need to be immediately before 53. Other pages are allowed to be between them. Okay, this all makes sense so far. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update, 75, 47, 61, 53, 29. Okay, so this is a line. Okay, so this is a group of 5. Means the update consists of page numbers 75, 47, 61, 53, and 29. Okay. To get the printers going as soon as possible, start by identifying which updates are already in the right order. Oh, okay, this is cute. Let's see. In the above example, the first update, 74, is in the right order. 75 is correctly first because there are rules that put each other page after it. 75, 47, 75, 61, 75, 53, 75, 29. Okay, let me do a control F for 75. 75 does appear on the right-hand side of the puzzle, and it would have to come after 97, but it looks like 97 is not in this puzzle, so that's a pretty quick way of validating that. Okay. 75 in the correct order because there are rules that put each other there. Okay. 47 is correctly second because 75 must be before it, 75, 47, and every other page must be after it according to the rule. Oh boy. Okay. Because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. Okay. Okay. I'm getting this. The second and third updates are also in the correct order according to the rules, like the first update. They also don't include every page number, and so only the ordering rules. Within each update, the ordering rules that involve missing page numbers are not used. Okay. The fourth update is not in the correct order. It would print 75 before 97, which violates the rule 97 pipe 75. The fifth update is also not in the correct order. Okay. For some reason, the elves also need to know. Oh God, there's already more. We're not even at a part 2. For some reason, the elves also need to know the middle page number of each update being printed. Because you are currently only printing the correctly ordered updates, you will need to find the middle page number of each correctly ordered update. In the above example, the correctly ordered updates are... Oh, okay, so this is how we can construct the final answer. Okay, this isn't an extra part of the puzzle. This is just, here's the numbers you will have to extract to generate the final answer. Yep. And then you have to add them up. So we take the sum of all the middle numbers of all of the updates that are in the correct order. Okay, following. This makes sense. Determine which updates are already in the correct order. What do you get if you add up the middle page number? Cool. We are there. All right, so first things first, let's go grab our example input like we do for all the previous puzzles. And this is just a simple copy and paste. I'm going to copy this. We're going to pop over to the terminal. We're going to vim example input.txt. We're going to store it here. Make sure I don't have any stray new lines or anything. And cool, that looks good. Then we're going to go and grab the next set of input, which is the real input. And this is the one that is personalized for me. So in order to do this, what I'm going to do is I'm going to click this link down here, which says get your puzzle input, but I'm not going to share this. I don't know if it matters or not, but I'm not going to share this. This is not something that gets shared out. I'm going to copy and paste the whole thing from the website, go into the Vim document that I have open, paste the entire thing, and save it. And then, cool, I will reshare my terminal. And there we go. So what do we have in here now? What work did I do while I was off camera? We have example input, which looks like this. And we have real input, which looks like that. Okay, cool. Hey, we are getting somewhere. Let's try and figure out some rules here, because we already know some rules. Let's see if we can figure out any more. We know that if the number 75 comes here, we have to check, was there anything that comes before 75? And in order to find out if there's something that comes before 75, we have to look for pipe 75. And these are the numbers that must come before it. So there must be a 97 before that. Well, we're at the first number, so technically nothing come before it. So we can basically skip the first number. Yeah. Let me think about this. I'm already jumping ahead in my brain. I'm like, what if we reverse the order? Let's slow down and take things one thing at a time. If we check the second number, we don't have to look to the right of the number. We only have to look to the left. So if we check 47, we just have to make sure that... what do we have to make sure? We have to make sure if there's a rule, pipe 47, that these numbers have to come before it. So let me think about this. Yeah, if we're looking at number 47 here, we have to make sure that if there's a rule where the right-hand side is 47, which shows up multiple times. So for 47, there needs to be if there is numbers before it, it can be a 75, it can be a 97. How am I gonna describe? I have to describe this rule in a way that makes sense to program. I love these puzzles. They're so intuitively honest or obvious, but turning them into code is so tricky. Let me see. So if I were to make sure that this was valid, how would I do it as a human? I would look at 75 and I wouldn't even care. I would just look at the next number. Like, is 47 in the right place? The only way to determine that is to make sure that if there's a set... Okay, you know what? I have an easier way of doing this. We look at the number 47 here. So we skip the first element because there's nothing to the left of it. We start at the second element, and then we find all the rules where this number shows up on the end. So pipe 47. So there are two rules, and the rules are there has to be a 97 before it, and there has to be a 75 before it. Let me reverse that. There can't be a 75 to the right of 47, and there can't be a 97 to the right of 47. Cool. Once we satisfy that rule, then we move on to 61. So pipe 61, and then we ensure, okay, so there are three rules. So to the right of 61, we cannot have a 97, we cannot have a 47, we cannot have a 75. Cool. I'm going to not use this first puzzle as an example because we know it's in the correct order. I'm going to use one that we know will invalidate one of these constraints, one that's incorrect. So, where's the list of the ones that were correct in the puzzle? Here we go. The fourth update, 75, 97, 47. Okay, this one is not in the correct order. So the fourth one is not in the correct order. This is the fourth one. Cool, so this one is not in the correct order. So let's figure out why. 97 is the second number. We're going to use the little algorithm that I came up with. 97 is the second number. There's no rule for 97, so we're okay. Then there's 47. 47 must come after 75, 97 and 75. So there can't be a 97 and 75 over here. Cool. There's a 61. Am I cooking here or am I just going crazy? So to the right of 61 cannot be 97, 47. Hold on, I'm I'm missing something here. Let's use the fifth update because there are only 3 here and it's not in the correct order, and we break a rule pretty early. So this is good. This is really good that we break a rule. So let's use the fifth puzzle. This is this one. It's really small. There's only 3 numbers. So the second number here, 13. Let's check the rules. Pipe 13. There cannot be none of these numbers, 97, 61, 29, 47, 75, and 53. They cannot show up to the right of 13. So 29 is not 97. It's not 61. It's not 29. Oh, nope. It's broken because 29 shows up after 13. That's the constraint that it broke. The fourth update, it would print 75, 490. Wait, no, sorry. The fifth update, since it breaks the 29-13 rule. Okay, cool. I think we have a working algorithm. Now, the thing is, if I were writing this in a language with nested data structures, I would just create a map where this would be the key and all these values would be like, so everyone where 13 appears here, they would just be pushed onto onto some sort of data structure. I don't quite have that here. I can sheet it by making a big string separated by commas. It's less than ideal, but we might be cooking here. I don't have nested data structure, so this is going to make it difficult. But let's just start doing it. Let's start correct order. Let's just call it that. I probably should just call it part 1, but like, you know, who cares? All right, so we have correct order. While read -r line do done. Cool. So that's just a really basic thing. Will this break? Yeah, it will actually break because it's technically a syntax error to not have anything in this while body. So the first thing we want to do is we have to check. Okay, so the example inputs. Oh, I'm stupid. I'm not even showing the terminal, am I? Haha, there you go. This is the terminal. Sorry, here's what I've been working with. Just called it correct order. That's really all I've done. Nothing fancy here. So this file has 2 different types of data in it. It has the rules at the beginning, and then it has the different orders that we have to test at the end. So what we could do is we could read the file in once to get the rules, and then we can read it in a second time, and we can just skip over the parts that we've already read. We're not going to bother with efficiency here. We're just going to kind of be gross. So we're going to read the rules. We know that they are separated by pipe characters, so we can do this. And then we can read -r left-hand side, right-hand side. And so now we'll have the left-hand side of the pipe character, the right-hand side of the pipe character. And if -n left-hand side or can break. So what this means is once we encounter somewhere where the left-hand side is undefined, meaning we hit that line that was completely empty that separates the rules from the orders, then we will break out of this loop. So we should only process the rules here. We'll verify this by just echoing it. Cool. There we go. So now we have this. All right. So now we have this working where we have the rules at the top and we pulled them out and we correctly have the left-hand side and the right-hand side. Awesome. So now we need to construct rules based on this. And the way we're going to do it is we're going to use the right-hand side as the key and the left-hand side as the actual data. Now, like I said before, I would love to have a hash map of a vec. I would love to have an object of an array. I would love to have a dictionary of a list. But we don't have that in Bash. We don't have nested data structures. So we're going to have an associative array of the left hand, or of a number to a string, and that string will be a bunch of numbers separated by some character. Might just reuse the pipe character or use a comma or something. So what we'll do is we'll declare -a here, rules. This is an associative array. And then we will say rules right-hand side equals, is there a plus equals? There is. Will plus equal the left-hand side with a comma. Let me think about this. I think this is right. I think we'll have trailing commas at the end of them, but I think that will be okay. So let's do some testing now. Cool. Now that we have this, let's do a for key in our array. Let's actually loop over the keys. Do, done, value equals rules, key. Cool. Echo key equal value. So we should have constructed our rules here. Hey, that looks really good. So now we have the right-hand side, and inside it is a set of these. Now they do have the trailing commas at the end, so I think we can go through and just trim those off. But without even doing that yet, let's just do a little test, because we have the value here. We could read it into an array. Read-RA, A for array, R for not mingling backslashes, not trying to interpret them as anything special. We could do, I don't know, just call it numbers for now. And we will read in from value. Now we have to say that it's separated by, wait, no, we don't need to use, oh my god, wait, I'm making this more difficult than it needs to be. Don't separate them by commas, just separate them by spaces. Oh, I'm so just making this more complicated than it needs to be. Just separate them by spaces, and then we can do numbers, and this is an array. There we go. Now we actually have an array of numbers, and we can pull them out. Cool. We just store them as a string, and then we turn them into an array when we want to actually deal with the information there. Cool, cool, cool. So, so now we have the rules. Like we're on a good track now. So now read the orders and test them. Yeah, I just want to note this is debugging purposes. We don't actually ever really need this as part of the algorithm. So now, can I suggest something, or is that against the rules? If it's like a small thing or some like syntactical thing, I'm okay with that. But if you're going to try and give me like some sort of solution or help me solve the problem, I don't want that. I don't want someone to like try and give me the answer or push me in the right direction. But if it's like a small syntactical thing, if you're like, hey, did you know you could do this in Bash, or try reaching this tool? Like, hey, I'm cool with that. But yeah, no, if it's actually like suggesting like some sort of implementation, then no, please don't do that. I don't want to get backseated here. Yeah, no, I appreciate it. Yeah, I feel bad because I know a lot of people want to help, and I understand. If I was watching someone problem solve, like my natural instinct is to jump in and help, but like I love the puzzle solving process. I just stream it because I know a lot of other people love it too, and I love to share that. All right, so read the orders and test them. So now we need to do what we did here, where we read through the file, but we're going to do things a little bit differently here. So we're going to, how are we going to do this? I have a pretty cheesy way of doing this. So the rules, for anyone who doesn't remember, the example input looks like this, and we've already parsed this top part, and we broke out when we hit an empty line. So now we need to parse this bottom part. So we should go until we hit an empty line and then start processing the data. So the way we'll do this, they were separated by commas, so we'll put a comma here. Set the IFS to a comma. Read-RA will have an array of, we'll call it the order. So that'll be an array called order. And then we will say, let's see, should process equals false. This is just a flag. So what this means is we're going to go until we have a completely like blank line, and then we're going to set should process to true. It's a little bit confusing, but bear with me. So if dash n, how are we going to do this? I just need the raw input line. Actually, you know what? Throw this out. We're going to get the raw input line. We're just going to parse it line by line. If dash z line. So if the line is empty, then we're going to flip the flag on because now it's time to start processing, and we're going to continue. So we're going to move on to the next loop. Fee. So and then should process or continue. This logic might be confusing to some people, but don't start processing until we hit an empty line. And if we hit this part, it's not time to process yet. Keep looking for that blank line. Cool. So now that we're down here, hooray, it's time to test the orders. Cool. So now that we have, let me think about how we're going to do this. Now that we have an order to test, we are going to go through it and we're going to test it. So the line is the order. So read, we're going to turn the line into an array of numbers to test. So the lines are separated by, so each order is separated by a comma. As a reminder, it's the bottom output here, as you can see, separated by commas. We're going to turn this into an array in bash. So we're going to separate them by commas, read dash RA, and then we'll call it order. And we have to read in from the line. Okay. So echo checking order. There we go. So now if this all works, let's just go ahead and run the example. So it prints out the rules, and then it didn't actually print anything down here. So we didn't make it down here. So that's not great. I'm wondering about this dash Z here, but what we'll do is we'll do an echo line and we'll put single quotes in front of each one and we will just see what happens. Nope, I already know what happened. I already know what happened. We read the entire file here. We read everything in standard in here. And there's probably nothing else to read here. Let me double check my hypothesis. No, I'm wrong. I was wrong. We didn't actually read everything. So good news, we didn't do that. I was wrong. I just completely went down. I should have just tested first. If I would have just tested, I would have seen that we didn't do that. Yeah, wait, hold on. We already read here. So standard in has already been moved. I didn't even think about this. Oh my God. Standard in has absolutely already been moved. So we don't even need to do this logic. This is so much easier because we've already moved the marker down. Oh my God. This is so much easier than I've been making it. That's right, JK. Oh my goodness. Okay, we don't need any of this. Hooray, it's time to test the orders. We don't even need this. That's it. We're just going to loop over the orders. That's it. That's so much cleaner. This is so much cleaner. Okay. So now we have to remember our algorithm. We start with a number, and then we ensure that... So if we start with the number, well, I think we start with 47, we look up where 47 is. So 97 and 75 cannot come after it. Let me double check this. Look up 75, we look up 61. So 97, 47, and 75 cannot come after it. We look up 13, 97, 61, 29 cannot come after it. This one does come after it. This one fails the test. Okay, cool. So we loop through each number in the order, and then we grab its list and we make sure that none of those other numbers come into play. Oh my God, this is going to be annoying logic to write, but we are almost there. We're almost there. Okay, for, let's see, for for order num in order, these are going to get to be some dirty variable names because if I had more time, I could clean this up and make this more concise. Wait, do they call them pages or orders? If they just call them pages, maybe I should just be calling them that. I shouldn't make up my own name. They call them updates. Okay. So, you know, we call them order. Let's call them update. Yeah, let's use the naming that the puzzle uses. This is a good rule of thumb here. Okay. For update num echo, let's just make sure that we're on the right track here. Close. Right. They're separated by commas. There we go. Okay. So these are the orders. These are the update numbers. So what we have to do now, is take a little break. Let's see. Wish I had your Vim muscle memory. Hey, just use it for the past 2 decades of your life. You'll get pretty good at it. No, I would actually, like, not even kidding, take some time to learn Vim. I'm not the best at it, but take some time to learn it. My mindset is the same reason I learned the shell. If I'm going to spend a majority of my time in here, especially for my job, which I do, I should know how to use it. Like, if I'm going to be using these tools, I should get good at using these tools. So yeah, like, and knowing Vim is really, really helpful. It's a good rule until Eric names something sudo rm-rf/. It's a funny joke that you say that, but here's the thing. If your code's good, it shouldn't matter if it's named that, because at no point should I be executing user data as a command. So if something in this puzzle is named sudo rm-rf/ and that command somehow runs on my computer, that is only my fault. But also, based on what I have seen about Eric, I don't think he would actually do that. I don't think he'd even put you remotely close to being at risk of messing something up in a process of learning. So I don't think he would do that. He would probably do something cheeky, but not that. Loop each number in the update and check it. Cool. So now we're going to check this number, and the way that we check it is, how do we do this? I don't think we want this. I think we want nested for loops where we go over an index. Because once we have this number, we need to check all the numbers after it. So let me rewrite this. This might be confusing. It seems a little verbose what I'm doing here. There's a reason, I promise. Because now we have the I variable and the num variable. And the I variable tells you where we are, because then we can use that as a starting point for the next thing that we're going to check. So the next thing that we are going to check is we have to see, is there a rule for this number? Check to see if there are rules for this number. Okay. So the way we check to see if there's rules for those numbers by we look for rules, num, and then we'll pull this out into a variable. We'll just call this, like, you know, rule. Now we'll just call this s. We're just going to pull it out into some throwaway variable. Rules num. Can I do this? Let me just, I'm going to run this and check. I think maybe you do need this because it's an associative array. Yeah, I was treating that like a string. Yeah. Okay, cool. So now that we have the rules, what we can do here is we can read in from this. Num rules, we'll read it as an array. And we'll read from here. Num rules make it sound like it's the number of rules. Rules for num. Let's just see if this works. Okay. That works. So basically what's going on here, this is a little bit confusing. We're going to loop over each number inside the update, and then we're going to check to see if there's rules associated with that number. There may or may not be, but because we're reading it into an array, this array might just have a length of 0. So in the case where it's going to have a length of 0, we're just going to pass by it. So if there is any, or what we need to do now, oh boy, we need to loop over these rules for j equals... No, we don't have to do that. Now what do we do? Let me think about this. What do we have? We have 97, 13. Okay, 97 doesn't have a rule, so we don't have to care. 13 has a rule. None of these numbers can appear after 13. Okay, so in order to determine that, we have to loop over each number after it and make sure it's not one of these numbers. Oh my goodness, the amount of loops we need. Because we don't have any sort of contains method. We could probably abstract that. Let me do some thinking down here. We could do a contains where we give it the thing we're looking for. The needle is $1, and then if we shift it, the haystack are the rest of the arguments. So we can just do something like for hay, local hay, for hay in our haystack, which is all the arguments, do, done, needle equals hay and return 0, otherwise return 1. So what this logic does is we can check if an array contains a needle. So we could do something like contains foo array. We could do something like that where we'll look to see if the string foo shows up inside this, returning 0 if it does and 1 if it doesn't. This will help us reduce the number of loops that we have to get into. So now back into this logic, let's keep track of all the numbers that we have. We have a num that we want to check. And in order to do this, we need to get the rules for that number. So now we have all the rules. So we need to know if these show up. Okay, so we have to loop the rules for rule in rules for num. We have to loop these rules. This is wild. And then for each rule, we have to check to make sure it's not to the right of that number in the list. And in order to do that, we need to subscript the array based on I. Contains rule inside update. Is it like this? Yeah, it is like this. At I. So we have to start at I. I think we start at I plus 1, don't we? Yeah. I think we start at I plus 1. Let me do some testing. Actually, we're gonna learn some bash on this. Foo bar baz echo a. Cool. If we do :1, we chop off that element. Oh, we chop off the element. We start at element 1. Yes, can we do this? Hey, that works. Okay, we don't actually need the math syntax. Oh boy. What do we do if it does contain? If it does contain, then it's unsafe. Okay. Let's do this. Safe equals true. Let's assume it's safe. And then if we make it here, if contains, then it's unsafe. Then safe equals false. And we just need to break out of both of these. We need a function. We need a function here. I have to think about this. Yeah, we need a function here. May I ask you a question? What keyboard do you use? This is just the keyboard that came with my Mac Studio. So this is just like an Apple wireless whatever keyboard. I don't even know what it's called. Check safety, we'll call this function. This just gives us the ability to return early. And we're just going to dump all of this in it. Why did that indent weirdly? So now we'll do if check safety. Cool. And now we just need to make sure this function works how we expect it. Check safety should take the update as an array of all the arguments. Cool. And then we just need to make sure all these variables are local. Local I. We'll just define them here. Do we even need this? Does the read variable declare it as local? It might. I should double check this. I always just do this out of habit, but it might not even be necessary to be excuse me, to be honest. Oh boy. But let's just run it. Let's just see what we get. Safe, 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 unsafe, unsafe, unsafe. Is that what the original puzzle said? According to the original puzzle, the first update is safe. The second and third updates are also safe. The fourth update is not safe. The fifth update is not safe. The last update is not safe. Okay. Look at that. My algorithm works. We correctly identified which one is safe and which one is not safe. It's a little esoteric how we do it. Check to see if there are rules for this number, or extract rules for this number. Array might be empty. Loop rules and ensure they don't show up later in the update. Cool, and that's it. So, if they were unsafe, we skip them. And if they were safe, then we need to grab the middle number. So I'm assuming there's always going to be a middle number, like it's always going to be an odd number of things. We need to grab the middle number, and then we need to add them all up. So, like always, total is a cum. We're going to make an accumulator. We're going to initialize it to 0. This is just going to calculate all the totals. If it's safe, then what we will do is find the middle number and add it to the total. This is all we have to do here. So we need to grab the middle number. So in order to grab the middle number of an array, let's say we have an array spot 5. How do we figure out that array of length 5? How do we know the middle is 2? I intuitively know it's 2 because it's between 0 and 4. What's the math to do that? Let me think about this. Is it just divided by 2? It might actually just be divided by 2 and then just chop off the number, right? 5 divided by 2 is 2.5. Chop off the decimal point, we're at 2. 3 divided by 2 is 1.5. Chop it off, it's 1. 7 divided by 2 is 3. So 3. I'm just chopping off the decimal right now. 9 would be 4. I think you just divided by 2, right? Middle index equals the length of the update divided by 2. And that's it. And then we just grab the middle. Would be update. Yeah, let's just do IDX. Yeah, and then a cum plus equal middle. I think that's it. I think that's literally all we do. Total is 137. Cool. So let's go over here. They have middle page numbers of 61, 53, and 29 respectively. Adding these page numbers together gives 143. Okay, so we are wrong here. This is like a first, isn't it? Why are we wrong? So we should only be adding up the safe ones. Let me pull back up the terminal. Middle is middle. Okay, so when they're saved, the middle is 47, the middle is 61, and the middle is 29. Okay, the middle is 47. That is incorrect. The middle is actually 61. We can see that. The middle is 61. That's not right. The middle is actually 53. Okay, so we are incorrectly gathering the middle. So something about my assumption is wrong. If we did 5 divided by 2, it would give us 2.5, which would get reduced to 2, which would be the third spot in the array. How is that wrong? I've got to be doing something stupid here. I am doing something stupid. That's literally what I was missing. I was missing this array. So we have to break it into an array. Let's break it into a third. Let's make another variable. This will be easy. This is the length of the array update. The index will be the length divided by 2, and then we will index this. I know it's 3 lines, but very verbose. If we do that correctly, then we should get the correct answer, which is 143. There we go. We got it. Middle is 29, middle is 53, middle is 61. Hey, that's great. So let's get rid of this. Let's make the output look nice. Rerun it. And we can see that the total is 143, which is exactly what we are supposed to get. So now, if we were to run this against the real input, it's going to flash a lot to the screen. Total is 5509. That's the right answer. You're 1 gold star closer to finding the chief historian. We did it. We have a working algorithm in Bash. No external tools on this one. All pure Bash. So we nailed it. Nice. We got part 1 done. I'm afraid to see what part 2 looks like, but we have to, right? All right, give me a second. I'm going to take a little break. And nothing going on my phone. Cool. Break's over. Let's see. So cool. Thank you, My Hero Academia. Yeah, that's me. All right. Continue to part 2. Let's do this. I am scared. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. Oh no. Dude. This is so much more work. Okay. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. Yeah, this sucks. How did you do this? After taking only the incorrectly ordered updates and ordering them correctly, their middle page numbers. Oh, okay. So to get this sum, I throw out all the good ones and I reduce it to only the ones that are good. Or that are bad, and then turn them into good ones, and then figure out what the middle is. Thank you all for the applause, but part 2's got me a little scared, I'm gonna be honest. But that's fun. So let's go back to what we have here. Let's CP calculate correct order. Let's call this one part 2 because I don't feel like coming up with a clever name for this. Let's open up part 2. Oh, I misspelled needle. That's cool. Check safety. If they are safe, then we will continue. If they're safe, then we just don't care about them. And if we are here, order is unsafe, fix it somehow magically. So let's see. Let's comment these out, but we are going to need them later because we know they're good. Let's just print unsafe. Cool. So this should just do the same thing. Part 2, read in from example input. And it will, I'm going to stop printing the rules because we know that part works. There we go. So now if we run this, cool. So we know that 3 are unsafe at the bottom. Let's pull back up the website. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. I don't know what that algorithm is going to look like. Eric was right. This doesn't hold my hand with the algorithm. I'm going to have to come up with one that works here. For the above example, here are the 3 incorrectly ordered updates and their correct ordering. So how do I do that? How do I go from we broke a constraint, how should we fix it? I'll have to think about this. Let me think about this, because I think I've done problems like this in the past where, like, from the set of rules, I might be able to create a finite list of all the possible arrangements. No, that sounds like it'd be giant already. And then I could just grab one from that list. God, this is like, I've written this before for software where you have like different pieces of software that depend on other pieces of software. So you have to do dependency graph, dependency resolution to figure out what order to install them that satisfies all the constraints. But that took a while. Are associative arrays a thing in Bash? Yes, they are. They're absolutely a thing. Declare -a hi. And now we can just do hi. That's the name of the array. That was a bad array name. Let's use a real one. Let's just call it array. Foo equals 1. I didn't put an equal sign. We can do foo equals 1. Bar equals 2. And then we can echo array foo and get 1 back out of it. I also have this little function that I took from the Bash wiki called PR to print array, and you can just give it the name of the array, and it will print it in a nice little pretty print format. It's pretty convoluted, and it uses a eval, so it's a little bit complicated of a function, but man, is it super convenient. Something I definitely like for interactive use when debugging. I would just take this and toss it in a script if I ever needed to dump an array. So how do we... What's the algorithm look like? Oh yeah, no problem. What's the algorithm look like? We have this, and we need to... Why is 47 highlighted? 47 didn't even move. You swap the first 2 numbers between it. There's got to be some reason why these are highlighted, and maybe it's supposed to help you out, but like this is one of those things where like if I don't know some algorithm, I don't know how much it helps me, but I have to keep that in mind. Oh, sorry, they're highlighting the middle ones. He's highlighting the middle one so I can see what to add him up. Yeah, never mind. It's not part of the algorithm. I was reading too far into it. Yes, you swap these 2 numbers. Okay, so what happened here? We determined it was wrong because... let me see. We determined... I don't even know. Why is this one wrong? It would print 75 before 97, which violates the rule 9775. I'm curious, like I wonder if there's some algorithm like we failed because we found a 97 after a 75. Do we just take this 97 and move it to the left of the 75 and try again? I'm curious if this algorithm works. Bear with me. You find the number, and then you go all the way to the right until you find the one that breaks the constraint. When you find it, you grab that one that broke the constraint, take it out of the array, and move it to the left of the number you were just checking, and then retry. That's so much easier in other languages, but it might be doable in Bash. But I have no idea if that algorithm even works. I just made that up. Because then you'd have to recheck it at the end. That should take a while. It might, yeah. That algorithm might take a while. Let me think about this. I think I'm gonna try that. I'm gonna look into the code to see how feasible that would be to try. But that's my thinking so far. Because all this did was check safety. We checked to see. I have an idea. We return 1, which is false, and 0, which is true. So true meaning it was safe, and 1 meaning it was false. Instead of returning 1, I wonder if we should return where the problem number is. I have to think about this. Because we're trying to locate. We're trying to locate the problem number, and then we have to swap it. God, this sucks. So I'm coming at this from an approach of take the existing array, modify it ever so slightly, and then we might end up with something that works. I wonder if it just makes sense to extract all the numbers from the array, forget the original order, just have a dump of the numbers, and try to create an order of them that satisfies the constraint. I mean, obviously, we could just randomly sort them, but the amount of combinations is large. I'm not going to do it randomly, but I wonder if there's a good way to figure out the order. Like, if something has no rules before it, it should always be to the left. Yeah. This is just a dependency graph problem. Like, I know this is. I could take all the rules and generate one string of them that's valid, and then just pull out the numbers from it, and the order would stay the same. All right, what rules do I have? If I have a number, I know what numbers can't be to the right of it, so I know what numbers have to be before it. Yeah, I think my original algorithm is the way to do it. Go through the array, start from the left-hand side of the array, work your way to the right, the left-hand side of the order, look at that number, figure out if anything's to the right of it that shouldn't be to the right of it, and move it directly to the left of it. Not to the beginning of it, but just to the left of it. Or maybe to the beginning. And just keep doing that until you don't do it anymore. We'll mess around with this. We'll see. But some of this needs to change, because right now this just checks if it's safe. It doesn't actually give me any indication of where the unsafe thing was. So now that we know that we are dealing with an unsafe thing here, we need to, for I equals 0, I less than len I++, do, done. Okay. So now that we have this, we can get the num. Okay. Now we get the number out of it. Now we extracted the number from this update. So now we need to look. We're basically just recreating what this logic has, which is fine. I don't care. Yeah, we're just going to be duplicating some logic here, which is totally fine. Extract rules for this number might be an empty array. So if there are rules, then these are numbers that cannot show up to the right. So we're going to look for them to see if they show up to the right. It's going to yell at me if I use local here because we're not inside a function. We need the rules. We're going to loop over the rules. We don't need contains. We need to know exactly the index of it. For j equals 0. No. J equals I plus 1. J less than len j plus plus. Bear with me. This is the number we're checking. If there is a match, then this is why it's unsafe. Unsafe at index j. This is a crazy nested nonsense. Bear with me. I'm going to run this and we're going to see what happens. Okay. Part 2, read in from example input. Okay. So this one is unsafe, and there's unsafe at index 1. That means that this number is why it's unsafe. And I think this is right because this 97 needs to move to the beginning to make it safe. Checking update here. So index 2, wait, index 2 is 29, right? Is unsafe. Yes, and this one has to move back one to the left. Unsafe at all these indexes. All these index will need to be shuffled. Okay. We're getting somewhere. I think we're onto something. Let's just ignore these. And then let's just put the unsafe ones down here. So all this means is the output's only going to show the unsafe ones because we're already skipping over the ones that were safe. Don't echo dash end this. Okay. So because we know it's unsafe at index 1, what we need to do is we need to shuffle those two numbers around. And the way we can do this is we can construct a new array where we shuffle those two numbers around. Let me think about how to do this. We'd have to overwrite the original array. And the original array is what? Update? Yeah. Let's construct a new array. Okay. And the new array will have the old array at the beginning, which we called update. It will go from 0 to I. We'll double check some of this logic to make sure it's right. I'm going to be off by 1 in so many different places. And then it will also end at j until the end of the array. Kind of gnarly, I know. This is very confusing. But if we print this, we get a syntax error. Nice. Where's the syntax error? Here it is. Okay. So we've constructed a new array, 97. We're missing 75, 61, 53. 47, 61, 53. Okay, cool. We are on to something. I think we want -1 here. And this will leave room. But we might be subscripting the array to nothing. I didn't think about that. That's super annoying. How do we do this? Let me think about this. No, I think we do want this. Maybe we want j plus 1. Yeah. The new array is 47, 61, 53. Okay, cool. The new array is just these 3 end things. We left out the first 2 because we have to put those back in. There was a problem in index 2, so the new array is just 61 because we have to put back in these 2 numbers because these 2 numbers were the problems. Okay, I think we're still on to something. Let's see. So in here, we have to put the 2 that we're swapping. And the 2 that we are swapping is num and check num. We have to do them backwards. Check num and num. So we're putting these back in the array, but we are swapping their location. So we've created a new array with the swap. So the new array is 97, 75, 47, 61, 53. And spoiler alert, that's correct. Go back here. The new array is 61, 29, 13. Spoiler alert, 61, 29, 13. Okay, we are on to something. The next one is wild because it needs to change and be an iterative process, but we are absolutely on to something here. Now that we have this new array, we need to store it as the one that we are currently checking. And the way we do that, I think, is just do this. I don't think there's anything else that needs to happen. Like, I literally think this is right. We need to break out of this 2 levels. Yeah, we need to break 2 levels out of this, so I think we can just do break 2. Bad array subscript. Well, that wouldn't work. So this one's right. 61, 29, 13. This one's right. New is 97. This one's not even close to right. This one doesn't even have a right one. Yeah. Line 59 has a syntax error for that one. So something's not quite right. Bad array subscript. Doing this in Bash? Whose idea was this? Okay, array changed, array changed. Okay, so with this one, array changed. Yeah, we changed an array from somehow being of size 5 to suddenly it's size 4. So that's not right. Something we're doing there is very much incorrect. I think I know why. I think I know exactly why. I think because the rule violation could technically happen anywhere. There's no rule that says these numbers have to be directly next to each other. Yeah. Yeah, we're not perfectly constructing the same array anymore. Is there a way to remove an index from a bash array? Can I just like pull something out? Let's learn some syntax together. A, B, C, D, E, F, G. Cool. Now, can we just pop something off of this? I don't actually know the answer to this. We can. We can literally remove stuff from an array. But then how do you put it back in? Yeah, I don't think this is a thing. I don't think I can say, like, put something in there, like at spot 2, and push everything over. I can make room for it. Okay. I think we can get there. I think we can get there. I have enough syntax to be able to do what I'm picturing. You can push it to the end, but not in a specific spot, right? Correct, correct. In order to put it in a specific spot, I'd have to make a new array and subscript the old array. But I think I can do that too. And I have plans for doing that. Because now that we have found the violating rule, we have to remove it. Yeah, now that we've found the violating rule, we have to unset it. That's what we have to do. We have to unset update at J. That's what we have to do. And I think we have to change this J plus 1 to just J. Okay. So now our new array has 8,000 different things in it. Okay, well, that's incorrect. Yeah, so that somehow that array just grew. Let's see. Yeah, this should never change in size. So I'm doing some math wrong here. Actually, wait, let's do more testing. That means start at 0. Does this mean give me 0? Yes, perfect. Okay, so this will work if it's 0. Then we put the check num, then we put the num, and then we start at J, which is 1 higher than, which is where the problem was. No, I don't think we want that. Yeah, I think that's what's wrong. I think we want to start at I plus 1. I think that's what we want. Now we're still having a problem when we do this. Okay, this is annoying. Yeah, no, the array is just growing like crazy. Because this is not at all we want. We're trying to create a new array after having unset something from the array. Yeah, so we remove the problem. We start at 0 and work our way all the way over to I, which is the number we're currently looking at. If we're looking at number 3. Oh, wait, hold on. No, this is correct. This is correct. We put the check num in there because we got rid of it. We put the number back in, and then we start at I. It's got to be I plus 1. But we're still getting the wrong thing. Is it I plus 2 because there were 2 things that we pulled out? That can't be right. It might be right. Let's see. The new array here is 97, 75, 47, 61, 53. That's correct. 61, 29, 13. That's correct. 97, 29, 29, 47, 13. Yeah, that's wrong. Okay. But I like the effort. So we moved this 29 here. We moved the 13 here. But then we somehow retained the 29 here and lost the 75. So somehow we're losing it. I'm trying to... Maybe I'm just trying to do too much here. Maybe I just need to do this. Unset I and unset J. 0 will read up until I. We'll put the check num in. We'll put the num here. And then we're going to reconstruct it with I plus 2. Maybe I am just trying to do too much. Hey, 97, 29, 29, 47, 13. Yeah, that's not right. Go. Smaller array is... Oh, I see. Never actually becomes a smaller array. Why does this not work? How did I unset before? Oh! Maybe because I'm dumb. Maybe that's why. Maybe this unset notation is just wrong. Yeah, I was expanding the variable and then trying to unset it. I think you just do it like this. I think that's how you do it. Okay. Yeah, so now we're going to have some issues because of how I chose to do things. I plus 2 is definitely not right. I plus 1 is the way to go. 97, 75, 40. Let's go to this one. This one's the one that's broken. 97, 29, 47, 75, 13. Okay. It's different, but it's not valid. So there was a risk of this happening. Like, I wasn't even sure that this was the correct algorithm to do. But we are onto something here. So what we did is we found the problem number and the rule it broke. We removed them from the array, and then we put them back in the array. Okay. So we removed 13 and 29 because those were problems. And I'm looking at the original array. They might be. I don't know. We removed 13 and 29. Which gave us 97, 29, 13. At no point is any of this right. Which gave us this new array. Oh, I think we have to keep checking. No, we shouldn't have to. So what do? We remove 13 and 29. So we put 29 and then 13 here. Now we would have to check that same number. We have to check that same number. That's what's going on here. We have to recheck it. Yeah, we break 2 out of this, which brings us down to here. And then we redo the loop. Oh boy, I think we need one of these bad boys. This is terrible code and needs to be cleaned up desperately. But let's think about this. We break out here. Okay. We're doing this a little bit backwards. This is okay. Swap these. Swap these. And if we change the array, we need to try again. We need to continue to, but we need to decrement J. So it'll start again. This is gnarly if this works. There's no way this should work. And it doesn't work. Cool. But we're getting somewhere. The first 2 puzzles work. This one is where things get bad. Why is it 13, 13, 13? 97, 47, 13, 13, 13. How did that even happen? 97, 75. Okay, so we pulled out 13. We pulled out 75, and we reconstructed by putting 75 and 13. Then we checked it again. We pulled out 75 and we pulled out 29. And then we put them back in, 29, but we're left with a 13, 13. So at some point we lost the correct number. Just gonna save us some indenting here. Okay. So, what's happening here? Let's continue 2 is throwing me off. But I think we're onto something. But we shouldn't be getting the same number over and over again like that. I'm not sure how that's being added back in, but it's going to be some subscripting thing. The only number that's being modified here is J as part of these 2 loops. J is 1, 2, 3, 4, 2. J is 2. Yep, J is 3. Yep, so we're repeating it. J is 3, J is 4, J is 4. Yeah, that seems right. That's what I would expect to see from this. I wonder if I should just try again. Like, just try again. I might just have to put this whole thing in a loop that gets called recursively. I might have to put this in a function in order for it to make sense. Let's see. This is a lot easier to read. Yeah. All right, let's see. Checking index 0 of num97. Cool. Checking index 1 of num13. Okay, so this one had a constraint violation, which we do know that that's correct, that happens. And now that we have a constraint violation, we have to go through and do our little algorithm where we remove the two problem numbers, which are 13 and 75. Those are the two problems, and then we swap them. So we put 75 before 13 and then put the rest of the array here. And then we check again. And once that happens, we might want to go back to this one and double check it, right? Do we just do I minus minus and continue 3? Just break back up into this loop up here? Maybe. 97, 75, 47, 29, 13. Oh my god, that's right. That is the correct answer. That is correct. 61, 29, 13. That is correct. 97, 75, 47, 61, 53. Oh my god, that is right. Yeah, aneurysm 9. I think you were right. I think that's exactly what I needed to do. I needed to reset this whole thing and just check the whole thing again. Oh my goodness, that's a lot of logic, but I think that's right. I hate this. It really desperately needs some cleaning up, but it gets the job done. So if I just do this, the accumulator is 1, 2, 3, and if I pull up the browser, we should see that we should get 1, 2, 3. So it's right. Like, this is right. Yeah. So yeah, I think this is working. Let me remove this one echo that's annoying me. Yeah, this one shows up a lot. Yeah. So let's go ahead and test this on the real input. God, please work, please work, please work. Total is 4407. Let's fire up that browser. 4407. I'm so scared. Let's go. Let's go. Let's go. That's right. Drum roll. We got it. We got it. We got it. That's right. You are one gold star closer to finding the chief historian. You have completed day 5.